We are on Chapter 2 of Calculus. This chapter is all about differentiation. We're on the first section of it, the derivative and the tangent line. In this chapter and in this section in particular, I'm going to talk about the slope of the tangent line to a point on the curve, and I'm going to use the limit definition to find the derivative of the function. So just a little bit of history. The calculus grew out of four major problems that European mathematicians were working on during the 17th century. The tangent line problem, which is what we're doing today. We're going to do the tangent line. And then the tangent line is all about the slope of the points at that point on the curve. And using that point, that slope, we're going to talk about velocity and acceleration in other sections. And using that same slope, we're going to talk about minimum and maximum, and we're going to find the area. Use area problems with it. All right, so calculus is all about finding the slope at a point on a curve. So we know how to find the slope of a line. That's very easy to find the slope of a line. It's the slope between any 2 points. And between any 2 points on a line, no matter what 2 points you pick, you're going to have the same exact slope. So it's going uphill, so it's going to go up, and it's going to go over, and it's going to have a positive slope. I don't know, we could guess. It looks like maybe it has a rise of 2 and a run of 2, so maybe it has a slope of 1 on it. But we know how to find the slope of a line. That's what we're doing. But we're going to find the slope of a curve. So on a curve, there's all kinds of different slopes. What's the slope there? The slope here has to be 0, which is different than the slope here, and the slope over here, and over here. It's different at all the different points. You're going to have a different slope. But that's what we're going to do. And the tangent line, a tangent is a point at a curve where it slices through it at just one point. It doesn't slice it twice. Like if you hit it at the wrong angle, you're going to go through 2 points. The tangent line hits it at one and only 1 point. A secant line goes through 2 points. All right, so that's what we're trying to do. So what we do to find what the slope is on a curve is we use our limit definition. And so just like I was talking about to find the slope of a line, you take any 2 points and do the change in y over the change in x, and that's what the slope of a line is. So we're going to use that same exact formula on this. So on this curve, we're going to take 2 points and we're going to find the slope. But what we're going to do is we're going to take it so that the points come infinitely and infinitely closer to each other, so that we find the limit as the limit gets close to that exact point. What is the slope? So that's going to come in handy with what we did in the last chapter on limits. So let's see. So the limit is used to define the slope of a tangent line. And it's also used to define one of the 2 fundamental operations in calculus, differentiation. Differentiation is finding the slope at a point on a curve. And so like I said, it's slope. So this formula, the fundamental kind of theorem for calculus, is about finding the limit as the change in x becomes infinitely small. So up here on this picture, this change in how far apart the 2 points are, we want it to get infinitely and infinitely smaller until it becomes almost 0. So when that point and that distance between the 2 points approaches 0, we're going to know what that slope is because we've come really, really close to the point on both sides of it. So that's what we're doing. So this definition is the change in y. See, it's got f of x plus the change in x minus f of x over the change in x. That triangle means change. It's a fancy way in math to say change. So we're doing the change in x on the bottom here. So between these 2 points, we could call this point x1. This point over here is x2. So we're doing the change in x, x2 minus x1, over the change in y on top. And the change in y on top, again, x2 minus x1, instead of saying x2 minus x1, they call it the change in x. So on the top, this is the y. So this is f of whatever y2 was minus f of y. But again, y2 here is the change in x, how far over it went. So it's just slope. And a notation here for a remark here, when you see the little tick mark for a derivative, it's read f prime of x. So let's see if we need to read anything else here. So I'll just read it to you. Be sure you see the derivative of a function of x is also the function. Be sure you see that the derivative of a function of x is also the function of x. The new function gives the slope of the tangent line to the graph f at a point x, f of f, provided that the graph has a tangent line at that point. That's what was important. So provided that it's got a tangent line at that point. If it doesn't have a tangent line at that point, you can't differentiate it. And that happens when you have something pointy, like absolute value. We can't differentiate at that point. It doesn't have a slope. Or possibly it doesn't have a point there at all. So like if you got, let's see, a vertical asymptote, at that vertical asymptote, whatever it is, you can't differentiate at that value of x because there's not a number there. So you got to worry about the domain on the functions. Anyway, we're finding slope. Bottom line, we're finding slope. So on the next page, we're going to use that definition of slope, change in y over the change in x, as it gets infinitely small so that it becomes 0. So we're going to do that here on this problem. So we're going to do, if f of x is 5 minus x squared, the directions say to find the slope of the tangent line, and we're going to go a little above and beyond that. We're just going to go ahead and find the tangent line on it. So using that formula up here, the limit as the change in the x gets close to 0, we want to find f of x plus the change in x. So you could take that, you're going to plug that whole thing in for the x. Put the whole thing in. So that makes it 5 minus, not x, but x plus the change in x squared. And then it's minus the quantity f of x. So I put it in brackets, or you could have just used parentheses. I don't know why I use brackets. But you need to do that because you want to minus all of it. You want to minus all of the f. And then that's over the change in x. So again, all you're doing here on this is you're taking and you're plugging in x plus the change in x whenever there's an x. And then minus what f of x was. And f of x was, again, 5 minus x squared. All right, so I'll focus here. So the limit, we're going to drag that along here each and every time, as the change in x approaches 0 is 5 minus, let's go ahead and FOIL this out. So we have x plus the change in x times x plus the change in x. So FOILing that out, we got x squared plus x change in x plus, going on the outside, x times the change in x, and then times change of x times the change in x is the change of x squared. Just treat it like it's another formula that they have on it is they just use the letter h instead of that fancy change of x, and it goes a little better when you use the h instead of that. We'll do that on the next one. I think you'll like it better. So doing that then, it's minus all of it. So I'm going to go ahead and minus it while I'm there. So it's minus x, well, I won't do that to you. So it's minus x squared plus 2x change in x plus the change in x squared. I'm going to go ahead and minus that. So minus 5 plus x squared, and all that over the change in x. I went ahead and added these. X plus the change in x, x plus the change in x. That was 2 of them. 2 x's change in x. All right, so then we got to clean the mess up and things will get better. Now you might be thinking to do a limit, remember you can just plug the 0 in at any point, but the problem is if you plug it in right now, you're going to be dividing by 0, so we can't do that yet. So just continuing on here to clean it up. I won't be lazy, I'll write it out. So that would make it 5 minus x squared minus 2x change in x minus the change of x squared, and then minus 5 plus x squared. That's all what's on the top there. So I distributed the minus across here. So minus x squared minus 2x change in x minus the change of x squared. So the 5 is gone. The x squared is gone. That's kind of fun. So you're left now with the limit. Again, it's a change of x approaches the number 0. And what we have left here is negative 2x change of x minus the change of x squared over the change of x. So you can factor out a change of x on the top. So if you factor out a change of x, all you're left with on the top is negative 2x minus the change of x, and again divided by the change of x. So I took that one out, put it in the front, and there was 2 there, and now there's 1 left. So I'm going to cancel out the change in x's. So all we're left with then is, as the limit as the change of x approaches 0, I could put 0 in there now. Oh, I'll clean it up. So the limit as the change of x approaches 0, those canceled out. So we're left with negative 2x minus the change of x. All right. So as I was saying, when you put the 0 in now, it works. It's fine. We can do that. We couldn't do it back here because when you plugged it in, you would have divided by 0, and you can't divide by 0. So now when you plug it in, it's fine. That's gone, and you're left with negative 2x. All right. That was a lot of effort. And they wanted to know what the slope was at the point. So at that point, 3, negative 4, the slope is going to be, m is going to be, you plug it in. This is the slope formula for the line for all the points. So plug in the x. So negative 2 times 3 makes negative 6. So that's the slope. All right, so I thought we could overachieve on this one, and we're going to find the tangent line too for fun. So let's go ahead and graph that. It was 5 minus x squared was the original question. F of x is 5 minus x squared. Let's go ahead and graph it so that you can see a little bit better visually what we're doing. So 5 minus x squared. Graph. All right, you can see it's going through the 5 and then it's going upside down. And I'll grab a couple other points off it. So it's going between, well, let's see here, the table. Second table. Oh, going the wrong way. Okay, so down here on the table, we have negative 1, 4, and 1, 4. And then you got 2, 1, and negative 2, 1, and so on. And we want to find the slope of the tangent line is what we just did just now for the point 3, negative 4. Oh, I should have done a better job drawing. Because that point's on the curve. See right there? 3, negative 4. It's a point on the curve. So if you plugged in the number 3 on this, you'd have 5 minus 3 squared, or 5 minus 9, negative 4. So anyway, it's right there. So we want to know the tangent line to that point right there. So what you want to do is use the point slope formula then. Y minus y1 equals m times x minus x1. And we're going to plug in the slope what we just got, which was negative 6. And we got to plug in the point, 3, negative 4. So that makes it y plus 4 and x minus 3. So y plus 4 equals negative 6x plus 18. So y equals negative 6x plus 14. So that's kind of crazy. So 14, which is way off my picture. So let me see. If it was 0, it's 14. If it was 1, oh, if I use the number 1, it gets better. If I put a 1 in there, it's negative 6 plus 14 is 8. And if I put the number 2 in there, that would be negative 12 plus 14, which is also 2. So 1, 8 and 2, 2. All right, let me draw it. So the tangent line at the point 3, negative 4 is right here. It's the purple line I just drew. So it slices through right at that point. All right, let's do it again. We'll do it on the next one here. But like I said, let's use the letter H instead of the change in X. They use H sometimes, and that'll make it go a lot better. Let me get more paper. Okay, so doing it for the next one. We would like to find the derivative of t squared plus 4t at the point 1, 5. And so, again, the limit, as we'll say h approaches 0, of f of x plus h minus f of x over h. So instead of saying the change in x, we'll just say the letter h. Life goes better. All right, so again, using the formula here, we want to find the limit as it approaches 0. So as the distance between the 2 points gets really, really small, what's the slope? So put, again, x plus h in for the letter t. Here we've got 2t, so we got to plug it in twice. So that's going to make x plus h squared plus 4 times x plus h, and then minus f of x, which here is we'll put an x in for it. So that would make it x squared plus 4x, and then over h. So again, the original one was t squared plus 4t, and it's at the point 1, 5. All right, so I'm going to move this out of the way. All right, so doing the math on it again, you have to FOIL this out. So that would give you x squared plus 2xh plus h squared, and then plus 4x plus 4h when you distribute that, and distribute the minus there, so it makes it minus x squared minus 4x. You got to multiply everything times the minus. You got to distribute across all of it, just like you distributed the 4 across it. You got to put the minus across all of it. Okay, and so cleaning it up here, look, the x squared's gone again. What else can we get rid of? We can get rid of the x's. All right, so what's left over here is 2xh plus h squared plus 4h divided by h. So then we could factor the h out, just like we did before, and then divide that by h. So then you'd be left with 2x plus h plus 4. So as the limit approaches 0 of h, you can just plug it in now. We couldn't plug it in before because you would have divided by 0. If you put 0 in right here, that's no good. Just like on the other one when we did the change of x and plug that just means the letter x, h or something. The change of x just freaks everybody out. So when you put the 0 in, that's gone, and you're just left with 2x plus 4. So at the point 1, 5, the slope at 1, 5 is going to be 2 times 1 plus 4, or 6. So if you wanted to, we'll take a look at it here and make a picture of it. Oh, yeah, we'll make a picture of it. So y equals, turn the calculator on, y equaled x squared, and then minus 4x. And then let me show you a trick on the calculator. We wanted to find the slope at the point 1, 5. Check this out. If you go second and then calc, and choice number 6, dy over dx, you can just type in the number then. We wanted it at 1, just type 1. Bam, you get -2. Did I type that in wrong? Son of a gun. X squared, oh, I did type it in wrong. Oh, you're all probably laughing at me. I love you all, so anyway. I'm supposed to put a plus. All right, try it again. Okay, so at x equals 1, you go second calc, choice number 6, and just type in the number 1, and then bam, we got 6. So doing that other problem we did before, let's go back and look at that one. So we could put that one in again. So the last one there was 5 minus x squared. 5 minus x squared. So hit graph. And again, we wanted that one at the point 3, -4. So at the point 3, -4, go second calculate the derivative dy over dx at 4. So just hit 4, enter, and it says that it's -8. Oh no. negative 8. Let me see here. Did I type that one in wrong too? Now you guys are really laughing at me. Oh, when it at the point 3, did I type in a different number? So I can calculate the value, no, dy over dx when it's 3. And we get negative 6. There we go. I don't know what I did before. All right, you probably aren't going to watch me anymore. I understand. I'll miss you very much. All right, I'll see you for the next lesson.